In this lesson, you will learn how to use FortiGate to protect your network against viruses. In this lesson, you will explore the following topics: antivirus basics, antivirus scanning modes, antivirus configuration, best practices, troubleshooting. After completing this section, you should be able to use antivirus signatures, review antivirus scanning techniques, enable FortiSandbox with antivirus, differentiate between available FortiGuard signature databases. By demonstrating competence in antivirus basics, you'll be able to understand and apply antivirus on FortiGate. An antivirus is a database of virus signatures that is used to identify infections. During an antivirus scan, in order to be detected as a virus, the virus must match a defined pattern called a signature. Different vendors assign different names to the same virus. All vendors use the attack vector designation in the virus name. The vector comes at the beginning of the virus name. Some examples include W32, which represents 32-bit Windows, W64, which represents 64-bit Windows, JS, which represents JavaScript, which is cross-platform. Some vendors also use a pattern as part of their virus name. Some patterns detect only one virus per pattern. Other patterns are more flexible and can detect multiple viruses per pattern. The pattern that the vendor uses depends on the vendor's engine. Host-based antivirus software such as FortiClient can help at the host level. However, host-based antivirus software cannot be installed on routers. Also, guest Wi-Fi networks and ISP customers might not have antivirus software installed. So, how can you protect guest networks, ISP customers, and your own network from malware threats? Like viruses, which use many methods to avoid detection, FortiGate uses many techniques to detect viruses. These detection techniques include antivirus scan. This is the first, fastest, simplest way to detect malware. It detects viruses that are an exact match for a signature in the antivirus database. Grayware scan. This scan detects unsolicited programs, known as grayware, that have been installed without the user's knowledge or consent. Grayware is not technically a virus. It is often bundled with innocuous software, but does have unwanted side effects, so it is categorized as malware. Often, grayware can be detected with a simple FortiGuard grayware signature. Heuristic scan. These scans are based on probability, so they increase the possibility of false positives, but they also detect zero-day viruses. Zero-day viruses are viruses that are new, unknown, and therefore have no existing associated signature. If your network is a frequent target, enabling a heuristic scan may be worth the performance cost because it can help you detect a virus before the outbreak begins. By default, when the antivirus scan's heuristic engine detects a virus-like characteristic, it logs the file as suspicious, but does not block it. You can choose whether to block or allow suspicious files. The heuristic scan is an optional feature that must be enabled in the CLI. You can configure the action for the heuristic scan to pass, block, disable using the CLI command config antivirus heuristic. If all antivirus features are enabled, FortiGate applies the following scanning order: antivirus scan, grayware scan, heuristic scan. What if heuristic scans are too uncertain? What if you need a more sophisticated, more certain way to detect malware and find zero-day viruses? You can integrate your antivirus scans with FortiSandbox. For environments that require more certainty, FortiSandbox executes the file within a protected environment, VMs, then examines the effects of the software to see if it's dangerous. For example, let's say you have two files. Both alter the system registry and are, therefore, suspicious. One is a driver installation. Its behavior is normal, but the second file installs a virus that connects to a botnet command and control server. Sandboxing would reveal the difference. FortiGate can be configured to receive a supplementary signature database from FortiSandbox based on the sandboxed results. FortiOS is smart when it comes to determining what files are sent to FortiSandbox. FortiGuard provides FortiGate with information based on the current threat climate that is used to determine if a file should be deemed suspicious or not. FortiGate provides the administrator with granular control when it comes to determining what type of files are sent to FortiSandbox for further investigation. Administrators also have the option to use the FortiSandbox database in conjunction with the FortiGuard AV database to enhance their network security. You can update your FortiGate's antivirus database using the push method, schedule method, or both methods. Scheduled updates allow you to configure scheduled updates at regular intervals, such as hourly, daily, or weekly. You can also enable accept push updates, which allows you to add new definitions as soon as they are released by FortiGuard. This is useful for high security environments because FortiGate will receive urgent security updates as soon as they are released. Regardless of which method you select, you must enable virus scanning and at least one firewall policy. Otherwise, FortiGate will not download any updates. Alternatively, you can download packages from the Fortinet customer service and support website, require subscription, and then manually upload them to your FortiGate. You can verify the update status and signature versions from the FortiGuard page on the GUI, or you can run Diagnose Auto Update Status and Diagnose Auto Update versions on the CLI. Starting at FortiOS 5.6, the botnet IPs and botnet domain subscription is now part of the FortiGuard antivirus license. Multiple FortiGuard antivirus databases exist and can be configured using the CLI command config antivirus setting. Support for each database type varies by FortiGate model. All FortiGate devices include the normal database. The normal database contains signatures for viruses that have been detected in recent months, as determined by the FortiGuard Global Security Research Team. It is the smallest database and, therefore, performs the fastest scans. However, this database does not detect all known viruses. Most FortiGate models support the extended database. The extended database detects viruses that are no longer active. Many common platforms are still vulnerable to these viruses, or these viruses could be an issue later. The Extreme database is intended for use in high-security environments. The Extreme database detects all known viruses, including ones targeted at legacy operating systems that are no longer widely used. There is also a compact signature database that is used for only quick scanning mode. You will learn more about this topic later in the lesson. FortiGuard Mobile Security Service is a separate subscription from Antivirus Service. As more and more organizations allow you to bring your own device, BYOD, a mobile security subscription can ensure up-to-date protection against the latest threats targeting mobile platforms. Good job! You now understand the basics of antivirus functionality. Next, you'll learn about antivirus scanning modes. After completing this section, you should be able to apply the antivirus profile in flow-based inspection mode, apply proxy inspection mode, compare all available scanning modes. By demonstrating competence in all antivirus scanning modes available in FortiOS, you will be able to use the antivirus profile in an effective manner. When the antivirus profile is operating in flow-based inspection mode, two scanning mode options are available: full scan mode and quick scan mode. Full scan mode uses the full antivirus database, normal, extended, or extreme, depending on what is configured in the CLI, and the IPS engine to examine network traffic. The flow inspection mode engine starts scanning with a raw packet. The engine does not necessarily scan in order, and it must extract the payload to discover the viral payloads regardless of surrounding protocol details. Because the file is transmitted simultaneously, flow inspection mode scanning consumes more CPU cycles. However, depending on the FortiGate model, some flow inspection mode operations may be performed by a specialized FortiASIC chip, which improves performance. Flow inspection mode scanning caches a copy of the packet locally on the FortiGate and forwards the packet to the end client at the same time. When the last packet is received, FortiGate also caches that, but puts the last packet on hold and has the whole file for scanning. The IPS engine checks for the rule match and then sends it to the AV engine for scanning. Two possible scenarios can occur when a virus is detected. If the scan detects a virus in the TCP session when it may have already forwarded packets to the client, it resets the connection, but it doesn't insert the block replacement page. So the client may think it has encountered a network error and try again. The FortiGate IPS engine caches the URL, and during the second attempt to download the same file, the block replacement page displays immediately without engaging the antivirus engine. Even if the client has received most of the file in the first attempt, the file will be truncated and the client will not be able to open a truncated file. If the virus is detected at the start of the stream, flow inspection mode scanning can insert the block replacement page at the first attempt. As you can see on this slide, the client sends a request and starts receiving packets immediately, but FortiGate also caches those packets at the same time. When the last packet arrives, FortiGate caches it and puts it on hold. Then it sends the whole cached file to the IPS engine, where rule match is checked and passed to the AV engine for scanning after that. If the AV scan does not detect any viruses and the result comes back clean, the last cached packet is regenerated and delivered to the client. However, if a virus is found, the last packet is dropped. Even if the client has received most of the file will be truncated and the client will not be able to open a truncated file. Regardless of which mode you use, the scan techniques give similar detection rates. How can you choose between the scan engines? If your performance is your top priority, then flow inspection mode is more appropriate. If security is your priority, proxy inspection mode with client comforting disabled is more appropriate. This slide shows an example of the antivirus profile operating in flow-based inspection mode with scan mode set to full. Quick scan mode uses an IPS engine with an embedded compact antivirus database containing fewer signatures. Quick scan mode does have some limitations compared to full scanning mode in flow-based inspection mode. Quick scan mode cannot send files to FortiSandbox for inspection, use advanced heuristics, use mobile malware packages. Some entry-level FortiGate models don't support this method. Note, the quick scan mode option is only available in flow inspection mode. The IPS engine examines the network traffic for viruses, worms, trojans, and malware without the need to buffer the file that is being checked. It provides better performance, but the detection rate is lower. This slide shows an example of the antivirus profile operating in flow-based inspection mode with the scan mode set to quick. A good use case example would be to apply quick mode scanning to public Wi-Fi. Note, all inspection options using FortiSandbox and mobile malware protection are not applicable in quick scan mode. It is also important to note that you must enable SSL/SSH deep inspection to scan encrypted traffic. Each protocol's proxy picks up a connection and buffers the entire file first, or waits until the oversize limit is reached before scanning. The client must wait for the scanning to finish. If the virus is detected, the block replacement page is displayed immediately. Because FortiGate has to buffer the whole file and then do the scanning, it takes a long time to scan. Also, from the client point of view, it has to wait for the scanning to finish and might terminate the connection due to lack of data. You can configure client comforting for HTTP and FTP from the config firewall profile-protocol-options command tree. This allows the proxy to slowly transmit some data until it can complete the buffer and finish the scan. This prevents a connection or session timeout. No block replacement message appears in the first attempt, as FortiGate is transmitting the packets to the end client. With a proxy inspection mode scan, the client sends a request and FortiGate starts buffering the whole file, then sends it to the AV engine for scanning. If the file is clean, without any viruses, FortiGate starts transmitting the file to the end client. If a virus is found, no packets are delivered to the end client, and the proxy sends the replacement block message to the end client. Here is an example of what the antivirus profile looks like in proxy inspection mode. It contains the inspection options you've seen previously in the full scan mode flow-based profile, plus the inspected protocol section, which allows granular control over which protocols will be scanned. Note, you need to apply the antivirus profile to a firewall policy to scan the desired traffic for viruses. You also need to enable SSL, SSH deep inspection to scan encrypted traffic. This slide provides comparison of the different antivirus scanning modes. Good job! You now understand antivirus scanning modes. Next, you'll learn about antivirus configuration. After completing this section, you should be able to configure antivirus profiles, configure protocol options, review antivirus statistics, log and monitor antivirus events. By demonstrating competence in antivirus configuration, including reviewing antivirus logs, you will be able to use the antivirus profile in an effective manner. The antivirus profile can be configured on the antivirus page. Full scanning mode in flow-based inspection mode and antivirus profiles in proxy inspection mode provide the same inspection options. These options include treat Windows executables in email attachment as viruses. By default, this option is enabled, and files, including compressed files, identified as Windows executables can be treated as viruses. Send files to FortiSandbox Cloud for inspection. If FortiSandbox Cloud or appliance is configured, you can configure the antivirus profile to send malicious files to FortiSandbox for behavior analysis. If tagged as malicious, any future files matching the same behavior will be blocked if the Use FortiSandbox database option is enabled. Include mobile malware protection. Mobile malware protection contains signatures for mobile malware such as Android devices. It is also worth mentioning that mobile malware protection requires a separate license. From the antivirus profile, you can define what FortiGate should do if it detects an infected file. After you configure an antivirus profile, it must be applied in the firewall policy. Protocol options provide more granular control than antivirus profiles. You can configure protocol port mappings, common options, web options, and email options, to name a few. You can configure protocol options for both proxy-based inspection mode and flow-based inspection mode VDOMs. You can configure protocol options for proxy-based VDOMs on the proxy options page in the GUI or from the CLI. You can configure protocol options for flow-based VDOMs from the CLI only. To configure protocol options from the CLI, use the command config firewall profile-protocol-options. Protocol options are used by antivirus and other security profiles such as web filtering, DNS filtering, and DLP sensor, to name a few. Once protocol options are configured, they are applied in the firewall policy. So, what is the recommended buffer limit? It varies by model and configuration. You can adjust the oversized dash limit for your network or optimal performance. A smaller buffer minimizes proxy latency for both scanning modes and RAM usage. But that may allow viruses to pass through undetected. When a buffer is too large, clients may notice transmission timeouts. You need to balance the two. If you aren't sure how large of a buffer you need, you can temporarily enable oversized dash log to see if your FortiGate is scanning large files frequently. You can then adjust the value accordingly. Files that are bigger than the oversized limit are bypassed from scanning. You can enable logging of oversized files by enabling the oversized log option from the CLI. Large files are often compressed. When compressed files go through scanning, the compression acts like encryption. The signatures won't match. So FortiGate must decompress the file in order to scan it. Before decompressing a file, FortiGate must first identify the compression algorithm. Some archive types can be correctly identified using only the header. Also, FortiGate must check whether the file is password protected. If the archive is protected with a password, FortiGate can't decompress it and, therefore, can't scan it. FortiGate decompresses files into RAM. Just like other large files, the RAM buffer has a maximum size. Increasing this limit may decrease performance, but it allows you to scan larger compressed files. If an archive is nested, for example, if an attacker is trying to circumvent your scans by putting a zip file inside the zip file, FortiGate will try to undo all the layers of compression. By default, FortiGate will attempt to decompress and scan up to 12 layers deep, but you can configure it to scan up to the maximum number supported by your unit, usually 100. Often, you shouldn't increase this setting because it increases RAM usage. An antivirus profile in full scan mode, in flow-based inspection mode, and an antivirus profile in proxy inspection mode buffers up to your specified file size limit. The default is 10 megabytes. That is large enough for most files, except video files. If your FortiGate model has more RAM, you may be able to increase this threshold. Without a limit, very large files could exhaust the scan memory, so this threshold balances risk and performance. Is this trade-off unique to FortiGate or to a specific model? No. Regardless of vendor or model, you must make a choice. This is due to the difference between scans in theory that have no limits and scans on real-world devices that have finite RAM. In order to detect 100% of malware regardless of file size, a firewall would need infinitely large RAM, something that no device has in the real world. Most viruses are very small. This table shows you a typical trade-off. You can see that with the default 10 megabytes threshold, only 0.01% of viruses pass through. Before FortiGates can start scanning traffic for malware, you need to apply the antivirus profile, the protocol options, and the SSL/SSH inspection profiles on the firewall policy. In full SSL inspection level, FortiGate terminates the SSL/TLS handshake at its own interface before it reaches the server. When certificates and private keys are exchanged, it is with FortiGate and not the server. Next, FortiGate starts a second connection with the server. Because traffic is unencrypted while passing between its interfaces, FortiGate can inspect the contents and look for matches with the antivirus signature database before it re-encrypts the packet and forwards it. For these reasons, full SSL inspection level is the only choice that allows antivirus to be effective. Since the botnet database is part of FortiGuard AV contract, administrators can enable scanning of botnet connections to maximize their internal security. Enabling botnet scanning is very easy. You just need to enable it on the external interfaces of FortiGate. You can also enable scanning of botnet connections using the CLI in firewall policies, explicit proxy policies, firewall interface policies, and firewall sniffer. Note, if an interface role is set to LAN, FortiOS removes the option to enable botnet scanning. It is only available to interfaces that are configured as WAN or undefined. For antivirus scanning in proxy-based inspection mode with client comforting disabled, the block replacement page is displayed immediately when a virus is detected. For flow-based inspection mode scanning, if a virus is detected at the start of the stream, the block replacement page is displayed at the first attempt. If a virus is detected after a few packets have been transmitted, the block replacement page is not displayed. However, FortiGate caches the URL and can display the replacement page immediately on the second attempt. Note, if deep inspection is enabled, all HTTPS-based applications also display the block replacement message. The block page includes the following: file name, virus name, website host and URL, source and destination IP, username and group if authentication is enabled, link to FortiGuard Encyclopedia, which provides analysis, recommended actions, if any, and detection availability. You can go directly to the FortiGuard website to view information about other malware and scan, submit, or do both with a sample of a suspected malware. You can find virus scanning statistics on the Advanced Threat Protection Statistics widget on the dashboard. If your FortiGate is submitting files for sandboxing, it keeps statistics about the number of files submitted and the results of those scans. These statistics are separate from files that are scanned locally on FortiGate. If you enable logging, you can find details on the antivirus log page. When the antivirus scan detects a virus, by default, it creates a log about what virus was detected, as well as the action, policy ID, antivirus profile name, and detection type. It also provides a link to more information on the FortiGuard website. You can also view log details on the Forward Traffic Log page, where firewall policies record traffic activity. You'll also find a summary of the traffic on which FortiGate applied an antivirus action. Good job! You now understand antivirus configuration. Next, you'll learn some antivirus best practices. After completing this section, you should be able to recognize recommended antivirus configuration practices, log antivirus events, monitor antivirus and FortiSandbox events, use hardware acceleration with antivirus scans. By demonstrating competence in antivirus best practices, you will be able to configure an effective antivirus solution. The following are some best practices to follow when configuring antivirus scanning for use on FortiOS. Enable antivirus scanning on all internet traffic. This includes internal to external firewall policies and any VIP firewall policies. Since botnet is now part of the antivirus subscription, it is also recommended that you scan connections to botnets for any outgoing traffic. You should enable this on all external-facing interfaces on the FortiGate, including redundant or load balancing interfaces. Use deep inspection instead of certificate-based inspection to ensure that full content inspection is performed. Use FortiSandbox for protection against new viruses. Do not increase the maximum file size to be scanned unless there is a good reason, or you need to do so in order to meet a network requirement. Additional best practices to follow when configuring antivirus scanning include the following. Enable FortiGuard push updates to ensure that FortiGate receives antivirus updates as soon as they are available. This will help keep the FortiGate database up to date and offer protection against new viruses. Ensure that FortiGate has a stable connection to FortiGuard servers. Logging is an important part of managing a secure network. Enable logging for oversized files so that if there are files that are not scanned, you can be aware of it. Also, ensure that security events logging is enabled on all firewall policies using security profiles. Use FortiView to view relevant information regarding threats to your network. FortiView organizes information into network segments and breaks it down into various categories. FortiGate's main CPU is responsible for performing UTM and GFW inspection on the network traffic. FortiGate models that have specialized chips can offload inspection tasks to enhance performance while providing the same level of protection. FortiGates that support the N-Turbo feature can offload UTM and GFW sessions to network processors. N-Turbo creates a special data path to redirect traffic from the ingress interface to the IPS engine, and from the IPS engine to the egress interface. This can improve performance by accelerating antivirus inspection without sacrificing security. FortiGate models that have CP8 or CP9 content processors can offload flow-based pattern matching to CP8 or CP9 processors. When CP acceleration is enabled, flow-based pattern databases are compiled and downloaded to the content processors from the IPS engine and IPS database. This reduces load on the FortiGate CPU because flow-based pattern matching requests are redirected to the CP hardware. Before flow-based inspection is applied to the traffic, the IPS engine uses a series of decoders to determine the appropriate security modules that can be used, depending on the protocol of the packet and policy settings. In addition, if SSL inspection is configured, the IPS engine also decrypts SSL packets. SSL decryption is also offloaded and accelerated by CP8 or CP9 processors. Good job! You now understand antivirus best practices. Next, you'll learn about antivirus troubleshooting. After completing this section, you should be able to troubleshoot common issues with antivirus. By demonstrating competence in troubleshooting common antivirus issues, you will be able to configure and maintain an effective antivirus solution. If you are having issues with the antivirus license or FortiGuard updates, start troubleshooting with basic connectivity tests. Most of the time, issues related to updates are caused by connectivity problems with FortiGuard servers. Make sure that FortiGate has a stable internet connection and can resolve DNS, update.fortinet.com. If there is another firewall between the FortiGate and the internet, make sure TCP port 443 is open and traffic is allowed from and to the FortiGate device. Force FortiGate to check for new virus updates using the CLI command execute update-AV. Verify that the FortiGate device is registered and has a valid antivirus service contract. What if FortiGate shows valid license but the antivirus database is out of date? Check the current database version installed on your FortiGate and compare the version number with the current release on the FortiGuard website. FortiGate may not update the antivirus database if it is not being used, applied on a firewall policy. Make sure the antivirus profile is applied on at least one firewall policy. If you continue to see issues with the update, run the real-time debug command to identify the problem. What if you have a valid contract and updated database and you are still having issues catching viruses? Start troubleshooting for basic configuration errors. Most of the time, issues are caused by misconfiguration on the device. Make sure that the correct antivirus profile is applied on the right firewall policy. Make sure that you are using the same antivirus profile and SSL SSH inspection on all internet connection firewall policies. Add and use Advanced the Threat Protection Statistics widget to get the latest virus statistics from the unit. These are some of the commands that can be used to retrieve information and troubleshoot antivirus issues. Get System Performance Status. Display statistics for the last 1 minute. Diagnose Antivirus Database-info. Displays current antivirus database information. Diagnose Auto-update versions. Displays current antivirus engine and signature versions. Diagnose antivirus test, get scan time, end quote. Display scan times for infected files. Execute update-AV. Forces FortiGate to check for antivirus updates from the FortiGuard server. Congratulations! You have completed the lesson. Now you will review the objectives that you covered in the lesson. This lesson covered the following objectives. Use antivirus signatures. Review antivirus scanning techniques. Enable FortiSandbox with antivirus. Differentiate between available FortiGuard signature databases. Apply the antivirus profile in flow-based and proxy-based inspection modes. Compare all available scanning modes. Configure antivirus profiles and protocol options. Review virus statistics. Log and monitor antivirus events. Recognize recommended antivirus configuration practices. Log and monitor antivirus and FortiSandbox events. Use hardware acceleration with antivirus scans. Troubleshoot common antivirus issues.